All right, we're back. We're on page 132 of math analysis. Page 131 is a big deal, by the way. I mean, like, that one's worth going back, rewatching, make your own problems, see if you can do them. I definitely recommend that. Share some problems with friends, like whatever you want to do. You got to get good at that. That process is going to be the same every time. We're going to actually do it a couple times, I think, on this page, potentially. But we'll see. So this page is all about just like using vectors. Like most of the way from here to the end is just like doing types of problems that we can using vectors. So let's see what we got here. So find the smallest angle between the lines 3x minus 4y equals 6 and 2x minus y equals 12. All right, so I mean, all these problems we're going to try to use vector. Even if we know another way to do it, we're just going to use vectors just to get a sense of what's going on. So this first line here, do I know anything about it? I mean, subtract 3, divide by -4. So this has a positive slope, so I'm just going to do that. It has a slope of 3/4, so that's like less than 1. I don't really, I'm like worrying too much about this. Okay, so this will be 3x minus 4y equals 6. And then 2x minus y equals 12. So subtract 2. I don't know, like I did that and then I just didn't. So there we go. And then here, I'm always trying to get better at color coding things. 2x, so subtract, you get -2, then divide by -1, so you get +2. So it's like pretty steep. So let's say like here. So let's say this is 2x minus y equals 12. So one thing that I don't want to do, because I just don't need to, I don't want to find the intersection. Like the intersection actually does not matter in this case, and that's good to know. So you know what happens is when I'm zooming, it like really messes up the video, and then eventually it kind of catches up. Actually, I'm not sure it ever does. Now that I'm like talking and looking at the picture, that's distracting. I wonder if it's because I'm zoomed in. Can I zoom out while doing this? Okay, I just zoomed out, and I think that maybe it's synced up a little better. Zoomed in. Is it synced up? I don't know. Can you even tell? Probably not. Anyway, I'm going to leave it zoomed in. I don't know why I think that's better. So I'm going to make some vectors here. If you remember, we can just use the slope to make our vectors. So here, I'm going to say like this. Oh, gosh. This is y equals minus 3x divided by, so 3/4 x, and then like minus 6/4. The 6/4 doesn't matter. So my vector here, I'm going to say is delta y is 3, delta x is 4, so 4, 3. And then this, so that's for this purpley line. That's my purple vector. And then here, I get y equals, so -2, so 2x, and then -12. But again, the -12 doesn't matter. Like that might even not be right. I think it is right. But even if it wasn't, oh wait, highlighting the wrong thing. Hold on. Vector, so slope is 2/1. So delta y is 2, delta x is 1. So 1, 2. All right, now, haven't even begun to answer the question yet. What am I trying to do? Find the smallest angle between, okay, so the smallest angle is acute, which means I need the dot product to be positive. So I'm trying for this. So here, let's say that theta is going to be the inverse cosine of the dot product. So 4 plus 6 over the product of the magnitudes 3/4. So that's going to be 5. And then square root of 5. So this is definitely the smallest possible angle. So how do we know? I could have simplified that. I'm not going to, because I don't know what that is anyway, so it doesn't make a difference. This is definitely the angle. This is what we're looking for. So I know that this is what we're looking for because the dot product was positive. The dot product is positive, so let me just name this U, I'll name this V. So since U dot V is greater than 0, I know the angle is acute, so that's got to be it. If I had gotten negative, right? So say I use the vector -4, -3, which I totally could have, right? That's also parallel to the line. My dot product would now be -10, which is obtuse. All I need to do is switch the sign of the dot product. So really, if u dot v was less than 0 and I need an acute angle, I would have used the absolute value of u dot v, or I would have just gone back and switched the sign of the vector, like change its direction, right? So we got kind of lucky, not really, but sort of lucky in that our vectors went like this and like this. If we had had one vector going this way and one vector going this way, we would have found this angle. So we also, at that point, could have just taken the supplement of what we got. Any of those would have worked. So let's try one more, and then we'll split this page into 2 videos, I think. So find a pair of orthogonal vectors whose sum is the vector 3i plus 4j. This may potentially be a trick question. It may not be, but it might be a trick question. So I'm going to say that, so what am I trying to find? 3, 4. Okay, so maybe that's like here. 4, what? 3, 4. What is going on? 3, 4, right? So this is my vector. Well, why not do the super easy thing? Why not just do 3i and then 4j? That actually accomplishes the goal, right? I and j are orthogonal to each other. So if I'd rather that be in, dang it. I'd rather that be in black. Man, this is like, so my vectors. I'm going to use the vector 3i, and I'm going to use the vector. So this is, we were not given additional information. That's what makes this possible. So the next problem is going to be worse, but 3i and 4j definitely add up to 3i plus 4j. They're definitely orthogonal to each other. So they definitely fit the bill. So I'm going to cut this video here, come back in the next one where we'll do the more complicated thing where we need 3i plus 4j, but one of them needs to be parallel or in the same direction as I plus j. So it's like slightly different. It's actually a lot different, but we'll go through and we will do it, and I will see you there.